Hey guys, so I've continued to explore Aave this week, and today I wanted to take a look at the primary Aave Liquidity Protocol. So Aave is basically a liquidity market protocol, where as a user you can supply tokens into the liquidity pool and earn interest on them, and also borrow tokens from the pool using your supplied tokens as collateral. In this video, I want to take a look at the process of supplying liquidity and earning passive income in the form of interest. And so I'd like to go over how to do this from the UI, and then also from the perspective of smart contract code for application integrations. So if that sounds good, stick around and let's dive in. Okay, so before we jump into it, let's take a look at the high-level flow for supplying tokens and earning interest. So first, the user supplies tokens to the Aave pool either through a wallet or from a smart contract. In the case of the smart contract, you need to first approve transfer of the tokens that you're supplying, and I'll show you how to do that in just a bit. Once the deposit's complete, the protocol will send you back something called an aToken. An aToken is a kind of equity token which represents your share in the pool. So basically, there's an approach where instead of keeping track of every kind of token deposited by every user, because that can get complex pretty quickly, the protocol tokenizes the user's share of the pool instead. The aToken is an ERC20 token that has real value because it's collateralized by the pool. It can be traded just like any other token, and you can also use it as collateral on other exchanges, effectively creating a leveraged position. So this opens up a lot of different creative possibilities. All right, so here I am at staging.aave.com. This is the main portal for the Aave liquidity market, and this is the interface through which you can provide liquidity, borrow tokens, and also withdraw your liquidity. So the first thing I want to do here is simply connect my wallet. There we go. And it's a pretty straightforward interface. You can see the assets available for supply. So let's go ahead and supply some link. I'm going to click on supply here, and I think I've got almost 1,000 in my wallet. Again, this is Aave test link, so let's do 500. And I'm going to go ahead and confirm. That'll open up MetaMask so I can sign the transaction. Okay, I'll go ahead and confirm that. And it's taken quite some time for this transaction to go through, so we'll just have to be patient here. All right, great. So here's where it gets interesting. You notice here it says add aToken to wallet to track your balance. So that's the equity token that the protocol is sending back to us. So I'm going to go ahead and add that to my wallet so I can see it. So now I'll get an aToken showing up in my assets list along with all of my other tokens. And you notice here this is aLINK, so that the name of the aToken depends on whatever token that you've supplied as liquidity. So I'll go ahead and add that token. Okay, close that. And so first of all, we see here is my pool position. I've added 500 LINK token into the pool. It shows me the APY, so just under 0.01%. And I can withdraw it when I want to. And I've got an option here whether I want my tied up funds to be made available as collateral in the pool or not. Okay. Now let's take a peek in the wallet and take a look at that aToken. And so I'll go to my Assets tab. And here it is right here. And so the interesting thing is, and let me kind of expand this a little bit. All right, so the interesting thing here is that not only do I see my aLINK, but I can already see the interest piling up here. Although, of course, it's very small right now because I literally just supplied my tokens into the pool. But you can see this update in real time, okay? And so there's an important point to remember that your interest is going to accrue on your aLINK token, not directly on the balance here. So you won't see this change. This will remain 500 unless I do a withdrawal or add more. But here's where we'll see the interest. And you can see it's incremented already just a little bit. So if we check this back in a few minutes, we'll see that this has increased even more. So pretty cool stuff right here. Also, now that I've supplied some tokens into the pool, I'm eligible to borrow tokens as well, and I can borrow any token, not just the one that I supplied. And if we check again after a couple of minutes here, we see that we've got a bunch more interest here piling up in our aLINK, so that's always fun to see. All right, let's take a look at how you would do this. Actually, let's withdraw first, and then we'll take a look at how to do this from the smart contract code. All right, so let's say I'm ready to close out my position now, and so it's very straightforward. I just go over here and click on withdraw. And okay, so I've got a balance of 500, right? But if I've initially supplied 500 link. However, I've got some interest as well. So if I type in 500 just straight up, it's going to leave some interest in the pool. So if you want to, a little trick, if you want to withdraw everything and end up with a zero balance, I would just go like a little bit higher, and then it will automatically detect your current level of interest and sort of calculate it so that you've got zero link remaining. So that's what I'll do here. By the way, something really important about aTokens that I forgot to mention a little bit earlier. So when you add tokens to the liquidity pool, when you supply new tokens, those aLINK tokens are actually minted. Okay, so those are new ERC20 tokens that are minted at the time that you supply your tokens. And when you go through the withdrawal process, when you remove your tokens from the pool, those aTokens are burned, okay? And that just sort of represents that you no longer have any interest or share of the pool because you've withdrawn your funds and your interest as well. And so that's exactly what we're doing right here. So those aTokens will be burned. In other words, when we look back in our wallet, we'll see a zero balance for our aLINK tokens. And all of the interest plus our initial capital of 500 link will all show up under our link asset in the wallet, if that makes sense. All right, and looks like that transaction is complete. So let's go back to our wallet. And you see now we've got zero aLINK because all that's been burnt and sold back basically to the pool. And now we have our original balance, plus a little bit of the interest that we accrued in that short time. All right, guys, so that's pretty much it for the UI that I wanted to show. The borrowing is very straightforward as well. I think you guys can see how you would do that. And again, you have to have at least some tokens invested in the pool to be able to borrow. So that's why these are disabled at the current time. All right, so let's shift over to Visual Code and take a look at how you would do the same thing through smart contract code. All right, so I'm over in Visual Studio and I've created a new project with hardhat. So I'm not going to go through that process step by step here since I've done it in the last few videos, but if you guys do want to see that step-by-step process, check out either the ERC20 token tutorial or the more recent Aave Flash Loan tutorial where I go through that process step by step. So what I'm going to do is create a new contract, a new file, and I'm going to call it MarketInteractions.sol. Okay, and let's go ahead and open up that file. All right, so the first thing I'm going to do is add a pretty generic license identifier, followed by the Solidity version. So I'll say Pragma Solidity 0.8.10. And the reason I'm not using the latest version here is because this is what I need to be consistent with the Aave smart contracts that I'll be importing, which is what I'll do next. All right, so here are the imports that we'll be needing, and you guys can copy and paste this if you want from the project repo, which will be linked in the description of this video. This should look pretty similar. If you guys watched the Flash Loan tutorial, it's basically the same contracts. iPool, that is the pool interface, which contains all the methods that we'll need, like supply, withdrawal, request Flash Loan, etc. The iPool address provider will give us back the actual address of the pool. It's just an abstraction layer. And then ERC20 is needed in order to pre-approve the withdrawal or the transfer of the ERC20 tokens that we'll use to supply to the Aave pool. All right, so let's start setting up the contract. So I'll say contract. I'm going to call this Market Interactions. Okay. Now just a little bit of setup. We'll need an owner, so this is pretty standard. Address payable owner, and then we'll set that in the constructor. And then we'll need a couple of more things. Let's see, iPool address provider. Public immutable, because there's no need for this to change. Addresses, and you can name this whatever you want. I'm just using all caps since it's a kind of a constant. Provider, okay, and basically this is gonna give us back an address which we'll then use to get an instance of the pool that we can then interact with and call different methods on. So here's a placeholder for the pool variable. Public, also immutable, pool. All right, next we want to set up a instance of the link token. We'll use link again in this example, just like we did with the UI. So we need an address for that. Address, private. I guess this could be public as well. Okay. All right, so let me grab the token address, and I'll add these to the description of the video for easy access. And so no quotes there, just the address. And finally, a variable placeholder for the link token. All right, so far so good. Let's set up the constructor next. All right, and so this is going to take the address provider address, which is then going to give us the actual pool address. So as a parameter, I'm going to say address, and then let's do underscore address provider. And this is the same pattern that we used with the flash loan contract. Okay. And so this we can find, I'll add this to the description of the video as well, but just to show you, where you can actually find it firsthand. Where is it? V3 testnet addresses. All right, and there's a list of all kinds of addresses here for various contracts. And what I'm looking for, where is it? Pool address provider, this one right here. Okay. And so this is actually going to go in your deploy script. So I've set up a deploy script right here, and basically this is just a standard deploy script. The only thing you want to change is make sure that you have that contract address right here being passed into the deploy function as an argument. All right. So this is all going to be in the repo, so you guys really don't need to do this. You could just sort of use this as is, but just so you know how this kind of all connects together and works. So this is going to be passed into the constructor here, all right? And then we can say address underscore provider equals iPool address provider, and then we pass in that address, which at this point is a variable, address provider. Okay. Now we can get an instance of the pool, and we'll say iPool address provider. We'll use some intelligent sense here to speed things up. Now there's a method on this called getPool, and it doesn't take any arguments, just like that. All right, so now basically the pool variable up here is populated with an instance of the pool, and we can start to call methods on it, which we'll do in just a second. Let's set the owner, and we'll say payable message.sender. You guys have seen this pattern many times probably by now. And then finally, let's set up an instance of the link token. So IERC 20, and this takes an address, which, where is it? Link address, this one right here. There we go. And that should complete our initial setup. So let's go ahead and save that. And of course, you could make the token dynamic by including a setter function so that you could pass in the address of various different tokens and set them before each transaction. So, but we're just keeping things simple here and just using link token. So the next thing we're going to do is actually interact with the pool. So we'll look at how to supply liquidity. So let's just write a wrapper function first. All right, and then inside of that we'll call, pool.supply. We'll take a look at that in a second. Liquidity. All right, so just set up a generic wrapper function here. Now, all those methods that we're going to play with and kind of call are going to come from here. So let's take a look at that. Aave Core 3 contracts interfaces pool. All right, so this will give us kind of a roadmap of all the different functions that we have available at our disposal. And these are events. Scroll down to find the functions. And this is what I'm looking for, supply. So this is what we're going to use to actually add our tokens to the pool. And let's just kind of see what else is here. Withdrawal, we'll use that as well. There's borrow. I don't know if we'll get to that in this tutorial, and the one for flash loan is in here as well, flash loan. All right, so for now, let's grab supply, and I've already copied it. So I'm just going to paste it in here for reference for now, so we know kind of what parameters we need. All right, so supply, it takes asset, which is going to be the token address, the amount. And on behalf of referral code, we don't need to worry about that. We'll just use some default values. So let's at least make this dynamic to the extent that we can reuse it. And so we'll pass in like the token address and the amount. That seems reasonable for the first go around here. So let's say address, token address, and then amount, which is going to be UINT 256. All right, so at least those two will make dynamic. And then we'll set some local variables. Well, the ones that will actually pass into the pool function. So asset, this is going to be token address. And then let's see, we'll do UINT 256, amount equals amount. And then what else do we have? Address. On behalf of, we're not going to be using this, so we'll just set, we'll just set it to the current contract. Why not? And then we have UINT 16 referral code. Just set this to 0. All right, so now we can get rid of this reference code here. And now we'll make use of our pool variable up there. Call supply. And then this takes the asset, the amount, on behalf of, and referral code. Go ahead and save that. All right, and I'm seeing some red here, so let's take a look at that. No visibility specified. Oh, I forgot the visibility specifier. Let's make this external. And then what have we got going on here? Address provider. Oh, sorry about that. This should be iPool addresses provider. I should have copied and pasted. So just go ahead and update that if you made the same mistake. And then down here as well, iPool addresses provider. And then same thing here. Let's just update that so that we're all consistent here. Okay, great. And I'll resave that. All right, so we've got supply liquidity. Let's add a method to withdrawal liquidity. So we're going to kind of do the same thing here. Start with a wrapper function. Withdrawal liquidity. Okay. And let's external. We can mark this one as view, since we'll just be reading data from the blockchain but not modifying it. returns, we don't know yet, and let's just complete the sort of skeleton of the function. Let's refer back to iPool and let's find the withdraw function. It's going to be down a little bit further. Yeah, so I'm just going to copy this again and kind of paste it in the middle of my code here, even though it's ugly, just for reference. All right, so basically, withdrawal liquidity is going to return a uint of the amount withdrawed. So I'll say uint 256. Yep, that's all we need, the type there. Okay. And so asset amount and 2. So again, we want to specify the token that we want to withdraw and the amount. So we'll make these dynamic parameters similar to the last function. So I'll say token address and amount. So basically the parameters are going to be exactly the same as the supply liquidity function. All right, and so given that is the case, we can save a little bit of time by copying these first two here. And then 2. Okay, so the 2 address is just going to be the address of this contract. That's not going to change for this example, right? So we can kind of hard code that. Address 2 is going to be address and pass in this to get the current contract's address. Okay, now we'll use our pool variable again. Pool, we'll say pool.withdraw. And this is going to take in asset, all of our variables that we just defined, amount, and 2. All right, and we'll remove our reference code here. Oh, there we go. All right, let's see, what does it not like here? Function declared as view. Oh, this is not actually a view function, my mistake, because this is going to result in a transfer of tokens. So that's going to change the blockchain state. And then uint 256 unnamed return variable can remain unassigned. Let's see, so we're returning a uint 256. Let's double check. Oh, okay, got it. We need to actually return something from this function wrapper. Since we're saying that we're returning something, our inner function is returning a uint 256, but not this one yet. There, now it is, okay. So that'll fix that problem. Good, that looks good to me. All right, there's one other thing I wanted to do. Let's go back to the pool interface. There's a function that gives you the state of your account, the current state of things. So I think that would be interesting to try to get working. Yeah, this one, get user account data. So I'm going to go ahead and copy this, bring this over here. And let's go ahead and create a wrapper function again for this one. Let's just use the same name. All right, so we'll say function. This is just going to take a user address. Okay, now this one is going to, this one will be a view function because it's just going to basically return some stuff, some data. Okay, and so basically I'm just going to kind of copy all, these are all the things that it's going to return. So let's just get rid of that code, and I'm just going to paste this over a return statement. There we go. So we need to call pool dot basically the same function. And we pass in user address. And again, let's go ahead and return all this. Return. Perfect. All right, looking good. Go ahead and save that progress for now. So that completes the main functionality that we need to code in order to interact with the Aave protocol. Other than that, we need a couple of utility functions, which I'm just going to save us a little bit of time by pasting these in from the finished repo. These are functions that we've done before in previous videos several times, so don't want to spend too much time on these. You guys have probably seen these multiple times by now, but there's an approve and allowance for the LINK ERC20 token, and that's going to allow us to pre-approve a transfer to the Aave protocol. Get balance, just so we could kind of check things and see what the balance of the contract is for any given token. Withdrawal function to withdraw those funds back from the contract to a wallet, and just a modifier for only owner. So let's go ahead and save that, and we're going to be ready to deploy and test our contract. All right, so let's go ahead and deploy our contract to the Goerli Ethereum testnet. I'm going to open a new terminal and issue the hardhat deployment command. So this is going to run our deploy script, which we looked at just a little bit earlier. All right, and if all goes well, it'll compile and deploy the first time. Fingers crossed. All right, and that deployment was successful, so I'm going to go ahead and copy my address. Let's see. Deployed contract. That way I'll know what that means. And great. All right, so let's go to the browser, and we're going to be using Remix to test this contract. So Remix Ethereum should be like the first thing that comes up. And Remix IDE, this is what I'm looking for. All right, so I'm going to expand the contracts folder here, and as you can see, there's some stuff from past tutorials, so let's just rename the Flash Loan one. All right, let's say Market Interact. I think that's what we called it. Okay, so let's go ahead and zero out all the code there. I'm going to go back to Visual Code, and I'm just going to copy and paste this entire contract and paste this right into Remix like that. All right, so I'm just going to paste in the direct URL version of these contract imports here, and I'll add these to the description of the video so you guys can grab them too. And then from here, I just need the address. Okay, back to Remix, and let's go ahead and compile this contract. Make sure Market Interact is selected. All right, once that's done compiling, we can go ahead and go to the Deployment tab. Make sure that one's selected, and make sure that Injected Provider MetaMask is selected up here for environment. That way we're able to control this with our own external account. And then go ahead and paste in the contract address into the @address field. All right, and just go ahead and simply click on that. And that is going to give us the interface for our deployed contract. All right, so the first thing we're going to need to do before we can run this test is actually send some link to the contract so that it has something that it can send into the Aave protocol. So I'm going to go ahead and copy the contract address and go to my MetaMask wallet. Click on Send. Copy in my contract address, and then I'm going to choose link. There we go. And we'll do 500 just like we did with the UI example. All right, I'll go ahead and sign that transaction. All right, it looks like that's gone through, so let's go ahead and check the link balance on the contract to verify. And let's do get balance. And there we go, 500 with 18 zeros. That looks right. Now the next thing we need to do is pre-approve the transfer of some LINK token. And so this is going to take the amount. I'm just going to do 1,000, just overkill. And then the second parameter is going to be the address of the Aave contract, right? So I'll go ahead and put that approval through, and we'll have to wait for that to finish before we'll check the allowance, and then we'll go ahead with the actual supply transaction. By the way, if you're wondering where I got that address, the actual pool address, that's going to be right here. So you can just grab it from here. append, the amount of tokens, and then the second parameter is the pool address. All right, looks like that went through. So let's see, allowance is going to take also the pool contract address. So that should still be in my clipboard here. Oops, not the amount. Just the address this time. And there we go, there's our allowance. All right, so we can go ahead and test the supply liquidity function. And back to my notes here. Let's see. That's 10 links, so I actually want to do 500, right? So we'll just take those first 2 digits and replace that with 500. All right, so this is the address of the token that I want to supply, followed by the amount. So let's go ahead and hit supply liquidity. Good sign, MetaMask's opening, so it looks like there are no errors, at least that it's able to calculate. So we will go ahead and confirm that transaction and wait about 30 seconds. All right, that's gone through. So what we can do next is verify the balance of LINK and aLINK on our contract, just to make sure that things seem to have gone well. So this is the LINK token. This should be 0, right? And it is, good. And then if we check aLINK, remember this is our equity token. This is where the interest is going to be accruing. So we should have like some small amount of this token at this point. Oh, okay, well, we should have 500 plus some small amount interest. That's what I meant. And that represents our deposit plus interest. So that all looks good. All right, let's try the get user account data. And let's see if this gives us anything useful. So I'm going to copy the contracts address and feed that into this function. All right, looks like we got some stuff here. And if we want to kind of decode what all of these things mean here, we can refer to the pool interface, and all of that's kind of defined right here. So let me see if I can kind of pull this up side by side. All right, so total collateral base, the total collateral of the user, and the base currency used by the price feed. All right, total debt base, the total amount of debt. In the base currency, we've borrowed nothing right now, so our debt is 0. Available borrow base, the borrowing power left of the user in the base currency used by the price feed. And this is always going to be lower than the amount of tokens that we've supplied or the amount of collateral that we have, because the way Aave works is it works on a system of over-collateralization. So you have to have a certain percentage more in collateral than what you're actually allowed to borrow. And then the current liquidation threshold of the user. Liquidation refers to the process where your position is basically liquidated if the amount of collateral that you have falls below the allowed threshold. So in other words, if the underlying tokens of your collateral, if the value of those tokens dip down below that threshold, then your position will be liquidated. Okay, and so that's not necessarily a good thing. So that's why it's always good to borrow well below your allowed amount. Okay, and then health factor. I'm not exactly sure what this is, but somehow this maps to a current rating of your health, I guess, which takes the liquidation threshold and your current available borrow base into consideration. All right, finally, let's make sure that we can withdraw our liquidity out of Aave back into our contract with the withdrawal liquidity function. Now this is going to take a token address and an amount similar to the supply function. Exact same parameters. So let's go ahead and grab those parameters. All right, and we'll paste them right into here, and let's try our withdrawal. All right, and let's give a few seconds for that to settle. All right, that's completed. So let's first check our aLINK token balance, which should be 0 at this point. Oh, looks like our interest is still there. That's right, because we withdrew 500 even, right? Not 500,000,4855. All right, So we'll figure out how to deal with that in a second. Let's check our link balance. Yeah, this should be back to 500. That's what we started with, so that's correct, yeah. How do we withdraw that remaining interest? Let's see if we can withdraw. Remember when we did it with the UI, we were able to overestimate by 1. All right, so if I remove 500 and add 1, I wonder if this will work. Let's try it. No, okay. I see what's going on. I think when you do it with the UI, you're able to overestimate by 1, like I'd say withdrawal 501, and it would run some function behind the scenes which would fetch my exact interest, but here I've got to specify more or less exactly what the interest was. So let's try that. So I'm going to go back to aLINK and check the balance. The tricky thing is this is changing all the time, so I'm not exactly sure the best way to target that if I do it really fast. Okay, so let me go back here. Okay, that's 1, right? So how many? 1, 2, 3, 4, 5, 6. So I'm dealing with 6 digits here. 2, 3, 4, 5, 6. It's always difficult dealing with the 18 decimal places. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Let's try that. Oh no, I think I did need that 0, right? Yeah, let's try this. Okay, I don't know. We may leave like one little bit of interest in there, but we'll see how this works out. Interesting. I wonder if there's a way just to like withdraw all funds. I don't know. I didn't see that in the API. We may be doing this the hard way. So anyway, okay, looks like that's done. So we can check our balance again. 0, yay, success. We effectively withdrew all of our funds and the interest. So you guys could see kind of how that worked, I guess. Next time you could do it, all in with one transaction. Just takes a little finessing there. All right, guys, that'll wrap it up for this video. So as you can see, takeaway, if you just want to earn some interest on your crypto by supplying some liquidity to Aave, it's pretty straightforward to use the UI to do that. Otherwise, if you have some kind of integration in mind, you can utilize the Aave smart contracts to create a pool instance, and then you would have all those pool functions available at your disposal. So yeah, thanks for watching, guys. If you like this content, I definitely encourage you to subscribe to the channel. Please give it a thumbs up if you haven't already. And I've got a bunch more videos in the pipeline coming soon, so stay tuned for that. And otherwise, I will catch you guys in the next one. Peace out.